Hello everyone! We're going to do some word problems. So we've done a lot of law cosines, a lot of law sines. Now we're going to kind of draw the picture, see if we can create the problem that we need to solve. Sometimes if I don't give you the triangle, this can be a little tougher. So I made some kind of ridiculous word problems. Some of these are movie problems. They're kind of fun. This first one is the little tongue twister deal. Sally and Sean are selling seashells on the seashore 10 miles apart. Okay, so let's say here's my seashore. Here's Sally. And here's Sean, and they're 10 miles apart. Okay, carry on. Both can see the same ship on the horizon, so I'm gonna kind of like, okay, they're looking out this way. So there's a person standing here on the beach. You could look at Sean this way, or you could look out at the, looks like the boat out there. You can see the same ship. The angle between the coastline and the ship from Sally's perspective. So here's Sally. The angle between the coastline, this is the coastline, and the ship is 35 degrees. So this is 35 degrees. And then for Sean, the angle between the coastline from Sean's perspective is 45 degrees. So let's think about what we have here, and then we'll think about what we're trying to find. We're trying to find how far are they from the ship. So let's call this, I don't know, A. This can be my A, my B. It doesn't really matter which one you label which. Here's my boat out here, and I want to figure out the two distances. So I'm trying to find the sides of the triangle. Now, if they give you two of the angles, you can find the third angle by subtracting from 100. And since this makes 80, then that means this, or I said 100, but I mean 180. This is 100. Because they have to add to 180, that's 100. So that's cool. Now, think about what info we have. Angle, side, angle, or you could think of that as angle, angle, side. So either way, it's the same thing. We know we have an angle side pair, so we can do law of sines. So I'm going to say the sine of 100 over 10 is the sine of 45 over b. And also the sine of 100 over 10 is the sine of 35 over a. Now if I just cross multiply and divide, I can get my two values here. So remember, to solve this, we're cross multiplying. So we're going to multiply 10 times the sine of 45. And then you would have b times the sine of 100, so you would divide by the sine of 100 to get b by itself. So there's b, and I'll do the same thing here. 10 sine of 35 divided by the sine of 100, 5.82. So looks like Sally is 7.18 miles, and let's write that out. Sally is 7.18 miles from the boat, and Sean is 5.82 miles from the boat. There you go. Hey, make it a little bigger. Sweet. Bovat. Try again. There you go. Okay, it's a word problem, so it's not a bad idea to have a word answer. Here, clean up the format a little bit. Cool. So we just had these law of sines. I know I could do law of sines again because I had an angle side pair. Let's try another one. Jack and Jill are on opposite sides of a 200-foot wide canyon, and they're looking down. Okay, this is ridiculous. All right, here's my canyon. It's 200 feet wide. We'll say this is Jack, and this will be Jill. Jack and Jill. All right. So it says, Jill looks down at an angle of depression of 60 degrees. So remember, angle of depression means she's looking out. I'm going to draw it from the top of it, from the canyon. Oh, I can do it from here. It doesn't matter. Looking out and then down. So that is the angle of depression. So this angle that I'm just forming is 60 degrees. The angle of depression is 60 degrees. And what else do we know? Jack looks down at an angle of 35 degrees. So he's looking down at 35 degrees. And down here we have Leonardo DiCaprio apparently being eaten by a bear. Okay. Jack looks down at angle 35. Great. If Jack is going to shoot the bear to save Leo, how far should he sight his rifle? Okay, so first thing, if he's going to shoot the bear, that's this distance. We'll call that's the distance we're trying to find. It's the diagonal. He's actually trying to hit the bear. So it doesn't matter how far horizontal it is. It's how far diagonal he's trying to aim. Okay, so let's see. First thing we can do is find, I know I can find a missing angle. And I'm going to maybe relabel this. I think it would be more helpful if I call this the 200 up here. So while I'm thinking about it, let's say this is 200. Even though this is 200, this is the triangle I'm kind of looking at right now. So let's do 180 minus 60 minus 35 and I'll get 85 for my missing angle. All right, so that's cool. Whoa, 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 whoa. 85 right here. And I have now, let's see, angle, side, angle, or again, angle, angle, side, which means I can do law of sines. And I'm trying to find the distance here. So I will say the sine of 85 over 200, there's my angle, side pair, is the sine of 60 over my distance. So I can find that pretty quick. I will do 200 sine of 60 divided by the sine of 85. And get the distance is 173.87. 173.87. And I'll come back and answer the question better in a second. This is 173.87. And the second question is how tall is the canyon? So that would be this height right here. Now if you notice, we have a right triangle. So I know the hypotenuse. And even though it might not have given it to me, I can figure out this angle pretty easily. This would have to be, these at a 90, right? So this would be 55. Okay, so I can say now if I'm trying to find this distance, that would be adjacent hypotenuse. So the cosine of 55 is the height over 173.87. So I just need to multiply that times the cosine of 55. 99.73. So let's write that out. 99.73. It's a word problem again. So let's make sure we write it as a word answer. Leo. Wait, no, Leo's not taking the shot. Is it? Jack. Jack needs to take a 173.87 foot shot to hit the bear. Not the beat. And the canyon is 99.73 feet high. Okay, cool. Wait, get in there. There we go. Jack needs to take a 173 foot shot. That's this diagonal right here. And then I use right triangle trig to find the height. Cool. If you get the picture, again, not so bad. Try another one. Mark, Bob, and Seth are out camping. All the college roommates are out camping. That's fun. Let's see. We'll say this is Mark and Bob and Seth. Mark's 10 is 153 feet from Bob. And 200 feet from Seth, 201 feet from Seth. Seth is 175. So we have side, 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 and I want to find the angles between the campers. So I need the law of cosines, which, let me remind you of the law of cosines. A squared is b squared plus c squared minus 2bc times the cosine of angle A. It's the same thing, you're just going to switch the letters. So I'm going to do it with, I'll say like my A, like I'll call this A, I'll call this B, and I'll call this C. Just if it helps you see it. So A squared, if I want to find angle A, I'm going to use this formula, and I will say 175 squared equals 201 squared plus 153 squared minus 2 times 201 times 153 times the cosine of angle A. Remember, this is a two-step process. The first thing I'm going to do is get all of the squares on one side. So right now these are positive. I need to subtract them. So I'm going to do 175 squared minus 201 squared minus 153 squared. These are big numbers. Negative 33,185. So this is now negative 33185, and that equals this whole product. So that's negative 2 times the 201 times the 153 times the cosine of A. Those are all being multiplied. So to undo that, I'm going to divide by that whole thing. But when you do that, you need to make sure you put it in parentheses. So I'm going to divide by the quantity negative 2 times 201 times 153. If you don't put the parentheses, you will get it wrong. All right, so the cosine of A is 0.539. I will do inverse cosine, and now I have A is 57.3 degrees. A is 57.3 degrees. Whoa. Okay. A is 57.3 degrees. So 57. There's one. I'm going to do the same thing to find one of the other angles. It doesn't really matter which one you do. I'll do the b squared formula. It's basically the same thing. 201 squared is 153 squared plus 175 squared minus 2. 153, 175 times the cosine of b. So again, I'm going to subtract the square terms. 201 squared minus 153 squared minus 175 squared. And then I'm going to divide by the quantity, -2 times 153 times 175. And then just remember, that's the cosine of b. If you want to find actual b, you do inverse cosine, and you get 75 point, we'll say 75.3. So b is 75.3 degrees. And now the last thing, I will subtract from 180. 180. I mean, you could do log cosines again, but it seems like overkill. 57.3. So I get 47.4. C is 47.4. This is really annoying how it keeps doing that. So B was 75.3 and C was 47.4. And now I got all three angles. So I got my whole triangle solved. Sweet. All right, let's try another one. Forrest is eating dinner on one of his shrimping boats with Jenny. He's on Jenny 1, apparently. That's the name of his boat. And now we're going to do, let's see, you got Lieutenant Dan is on there. He's got a distress call from Jenny 2. All right, let's see. Maybe we should focus on the picture first. Let's call this guy Jenny 1. And this is Jenny 2. Received a distress call. Mama's sick and Forrest needs to go home. You've seen the movie, he hops off the boat. Jenny 2 is 2 miles from the dock. So let's say this is the dock out here. This is 2 miles and 4 miles from Jenny 1. So Jenny 2 is 2 miles from the dock and 4 miles from Jenny 1. From Jenny 2's perspective, there is 45-degree angle between Jenny 1 and the dock. So this is 45 degrees. So we have side angle side. Side angle side means I need to use law of cosines, and I'm trying to find how far he has to swim. So that's this distance here. He's going to hop off the boat and swim to the dock. So side angle side, law of cosines. Law of cosines would look something like this side squared, d squared, would be the other two sides squared. 2 squared plus 4 squared minus 2 times 4 times the cosine of that angle. That angle is 45 degrees. Since we have the included angle, this is easier because all I need to do is type in the right side. 2 squared plus 4 squared minus 2, 4, cosine 45. 8.68, you need to square root that because that's d squared, and I get 2.95. So the distance is 2.95. Ooh, that's sweet. D equals 2.95. But it's a word problem, so we'll say Forrest will have to swim 2.95 miles after he hops off of Jenny 1 to go see his sick mama. There you go. Okay. All right. Forrest Gump. Sweet movie. Keep moving. Oh, you're staring at a velociraptor. Okay. So sounds like a little Jurassic Park action here. And we got a door or something here. So I'm here. Here's me. And I'm staring at a velociraptor. I'm not gonna be able to draw a lot. There's his face. Rawr. This is terrible. There, and then there's his feet. Okay, and here's a little arm. All right, that's my velociraptor. It's lovely. He's staring at me, and I'm looking at the door, and he's looking at the door as well. So this is my escape. I'll try and draw it here. There you go. That's my escape. They can open doors, remember. From the raptor to safety forms a 100-degree angle. That's a 100-degree angle. The raptor sees your exit, and his path from the exit to you and the door forms a 30-degree angle. That's 30 degrees. If the raptor is 200 feet from the door, that's right there. How far are you from the door? That's this distance. So let's see. Do I have an angle side pair? Well, this is 130. That means this has to be 50. So the answer is yes, I have an angle side pair. And I don't even need that, but I do have an angle side pair. So I can do law of sines because I have angle side angle or angle angle side. I'll say the sine of 30 over the distance is the sine of 100 over 200. The cross multiply, 200 times the sine of 30. Remember the sine of 30 is 1/2, so that's 100. Divided by the sine of 100. You get 101.54. So the distance is 101.54 feet. All right, so this is 101.54 feet. Now, if the raptor is twice as fast as you, will you make it to the door in time? Okay, he can run 200 feet in the time it takes you to run 100 feet. So he's going to run 200 feet, you're going to run 100 feet, and you're going to be 1.5 feet short of the door, and he's not. So you will be 1.54 feet short of the door with the raptor waiting for you. You are lunch. Bummer. Better try something else. Because he's faster than you, and he's got, even though he's got more distance, he's twice as fast. So you're not going to make it. Matt measures the peak of a mountain at 35 degrees. Okay, I think we've done some of these. But now that we have more information, this is going to be easier. So let me see. I'm going to draw, this is my mountain. Okay, here's my mountain. It's a lovely mountain. There's a little snow cap and everything. There's my mountain. All right. It says, Matt measures the peak, here's Matt, of the mountain at 35 degrees. Susie, who is 1,200 feet closer, so somewhere in here, she measures peak of the mountain 42 degrees. Okay? And how high is the mountain? So we're trying to find this height. Okay, what else do we know? We know this is 1,200 feet. If this is 42, I can subtract, that's 138. Just, I'm thinking what I can label. Because now, to me, it looks like I got a triangle that I can solve. So I have angle, side, angle. I could find anything on this triangle, which I think, if I find this distance, then I'll be able to use right triangle trig to find the height of the mountain. So I'm going to find this hypotenuse. Because if I have the hypotenuse, then I can find the height of the mountain pretty easily. I don't need to do the system of equations that we did because now we have the law of sines and cosines. So angle, side, angle, I'm going to use law of sines. I'm going to say, let's see, I need my angle, side pair. This has to be 7 degrees because these add up. This is 42 and 138. So now I got all three angles. I can say the sine of 7 over 1,200 is the sine of 138 over my distance. And I can figure out my diagonal distance by multiplying 1,200 times the sine of 138 divided by the sine of 7. So that distance is 6588.7. So this is 6588.7. That's a long ways, but okay, fine. But now I have a right triangle, and I can use right triangle trig to find the height of the mountain. So I'll say the sine of 35, that's this angle, is opposite over hypotenuse. So all I need to do now is multiply times the sine of 35, and I'm good. Times the sine of 35, and now I know the height of the mountain is 3779.1. So let's say the height of the mountain is 3779.1 feet. Cool. So we use law of sines to help us get this missing side, which before we weren't able to do. We had to write a system of equations because we only knew right triangle trig. All right, home stretch. This is sort of the last problem. Let's see if we can wrap this up. First thing that we need to do is, let's see, what information do we have? We have angle, side. Oh no! Better be careful here. This is an ambiguous thing. We got to be careful. So we're gonna try and figure out what this missing angle would be. So let's solve for angle B. So we'll say the sine of 71 over 370 is the sine of B over 400. And now we'll multiply both sides by 400. So this is 400 times the sine of 71 divided by 370. This is the sine of B. Uh-oh. That's not good. The sine of B is 1.022. I doubt it. Oh, that's not right either. The sine of this. Oh, I gotta do inverse sine though. Inverse sine of 1.022. Error. You can't have a sine value bigger than 1. So this isn't possible. The sine of B, why does it keep doing that? The sine of B cannot be, what did I say it was? 1.02? No, it doesn't. Because the sine of B, the biggest it is 1. If you think about the largest value that sine ever has on the unit circle, the y value, the largest value, y value is right there at the top. It's at 0, 1. So you can't have a sine being bigger than 1. It's not on the unit circle. It's too big. So why can't you do this? Because this triangle can't be drawn. Whoever drew this thing up didn't think it through. So this isn't going to work because it's not legit. Now what else happens? This says angle A is, okay, now they're making it 61 degrees. So we'll take the same formula and we'll change it to 61. So let me get my calculator back out and I'll just change it to 61 degrees. And now we get the sine of B is 0.94. So I can do inverse sine and I can get that B is 71 degrees. So B is 71 degrees. But B could also be its supplement. Its supplement would be 109 if there's room. So let's kind of draw this and say, is that possible? Is it possible that I could draw this thing two ways? So if this is 61 degrees, then angle B would be 71 degrees. And if you add those together, you get 132. Okay, that's fine. That would be one of them. If you have 109 to 61, you get 170, which means there would be room for it. So here's what is happening here. You can take this length. If you imagine sort of this is like the perfect length. That would be your height. You can take that length and you can stretch it out this way. Or in this problem, you could also stretch it out this way. So there's actually two triangles. This would be 109 degrees if you drew it that way. You could draw it like this, or you could draw it like this. But there's two of them. So the question is, what information can you add to guarantee that this purchase goes through? Notice how on both of these triangles, that angle is the same, this angle, or this side is the same, and this side is the same. It's angle side side. So what could we do to fix it? They could give me this length, that would work. They could give me this angle up here, or if they just straight up told me something about angle B, that would work too. But you got to give me more information. Probably the easiest thing I would say is give me the length of this distance AB. But the important thing here is you understand if you are given angle side side, it is ambiguous and you need to know how to find both triangles. So that's all you got. That's a lot of word problems, but you're going to need to be able to do those to get through your stations. If you feel good about this, make sure you give them a shot and make sure you hit that like and subscribe.